Welcome everyone to Knox Game Design for October 2025. My name is Levi Smith. This month I'm going to be talking about a 3x3 puzzle cube. So I had one of these when I was a kid. Never learned how to solve it until recently. It took me 40 years. So once you know the algorithms and everything, it's pretty easy to do. I got down to where I can do it under 2 minutes. But this talk isn't going to be about solving the 3x3 puzzle cube, but it's going to be how to actually implement this in a game, and I'll be doing an example in Unity. So some of the basics of this puzzle, it has 6 total centerpieces, which are blue, green, orange, red, yellow, and white. And the trick is these never actually move. You can move them around. You can move its orientation, but you don't actually move those pieces. Then you have the edge pieces, which are kind of between the corners right here. So there's 12 total edge pieces. Each of these have 2 colors. And then there's corner pieces, which are in the corners, which have 3 colors each. And there's 8 total of those. So to start out, the way I implemented this is by modeling the pieces. I used Blender. So for simplicity, I just used one piece, one model for each of the pieces for all 26 pieces for all 3 different types. So what I did is I separated a standard Blender cube into 6 separate meshes for each side of the cube, and then just colored each side the appropriate color. I was able to separate the meshes using the separate by selection in Blender. Then I obviously renamed each of those meshes to an appropriate value, such as up for the top, down for the bottom, left, right, front, and back. And they're actually all positioned in the same way. So I created a new material and assigned that material for each side, and then exported that to FBX. So this is what it looks like in Blender right here. You can move it around. So typically the white is the top, green is the front, blue is the back, red is the right side, orange is the left side, and yellow is the bottom. So you can see up here, I got each of these broken out into separate meshes like that. And then I assigned a different material for each of these meshes, and that'll become really important once you bring it into Unity. Okay, so this is how I created it in Unity. First of all, I started out by creating a game object for a piece and attached a piece script to each of the pieces. I imported that FBX model into Unity and then made that a child of the piece game object. And then I attached the script to that piece game object. And then I created an instance variable for all the pieces in the game. And that gets assigned in the game manager game object. It keeps track of all of those. So I created a prefab from the piece so I can instantiate all the ones that I need, all 26 pieces, and set those in the appropriate positions. So here's a look at the code right here. I'll go over this in a little bit more detail, but yeah, I have a create pieces method right here with a position. So I basically loop through like all the front pieces and all the back side pieces and set the appropriate position based on their index. And then I created the top pieces, and then the bottom pieces, and then the ones on the left and right side. So the first thing I did after I have my pieces instantiated, I wanted to rotate a layer, or learn how to rotate each of the layers. So basically what I did is I created a list, a collection of the ones that need to be rotated, and then I used transform rotate around, giving it the point, the axis, and angle to rotate around that center piece for that layer. So here's an example: rotate layer F for rotate the front layer. So for each piece and the list of pieces to rotate it, so I basically grabbed all the pieces in the front, put it in this list right here. Then I call for each of those, I call transform, rotate around, and then you want to rotate around -1 in the Z direction. This front piece right here, you want to rotate around it, and then I just had it set to rotate 45 degrees for each second. Do that by multiplying that by times delta time right here. So it seemed to work pretty well. So after I got the front layer rotating, then I wanted to rotate all 6 layers. One thing I did is Unity 6 has a new input handler, so I removed it because I don't know how to use it yet. Maybe it's good, I don't know. I just didn't have time to learn that. So I used the old input. So you can see if get key down is key code U. Then what we're going to do, we're going to clear our list of rotated pieces. We're going to get all the pieces in the parent right there, and then for each of the pieces, if the transform position Y equals 1, then we're going to add that to the list of pieces to rotate. Then here's where we set the rotation point right here. Then I have a rotate layer method right here. And for each piece and list of pieces to rotate, we're going to call transform rotate around the rotation point, 9 degrees, times time delta time. So we're going to rotate 90 degrees in 1 second. So basically I went through and created methods. Well, actually I just made that a little bit more abstract. So I have one rotate layer method for all of the layers. And I just modify which one is the rotation point by setting this vector rotation point value right there. So that lets me like rotate the top layer, the bottom layer, left, right, front, and back. So once it's rotating, you need to know when to stop the rotation. So what I did is I kept track of the number of degrees that it's rotated on each update, and then when the degrees of rotation is greater than or equal to 90, I stop the rotation. The very important thing that I learned when doing this method, you want to use mathf round to int for comparing and setting the final position. So you should set it as close to -1, 0, or 1 as possible for the location of the piece in its final position. But it may not be exact due to floating point precision in Unity. So if you try to test the location of a piece and it's a floating point, you want to see if the front piece right here is -1Z, then you're probably never going to get true because it's going to be a little bit off by floating point fraction there. You can also try using mathf approximately, but it still may not turn true. I tried that and it was different. I got different results and it wasn't reliable, but using the mathf round to int, that seemed to work every time when doing the comparison to figure out if it's in the right location. And one thing you want to check, make sure that you don't allow a layer to be rotated if the pieces are already being rotated. After I did that, I figured out how to calculate the wind state right here. So basically what I did is I set all the materials on each piece to blank by default. I only set the color on the valid sides, and I added the check solve method. So for each centerpiece, you want to check, if you got green on the centerpiece, you want to check, make sure that all the other ones are green. If you got red as the centerpiece, you want to check, make sure they're all red on that side. So you want to do that for all 6 sides. And if they're all equal to the center color piece, then you know the puzzle is complete. It's in the win state. So you want to check that every time the moved layer stops after a move. You don't need to check that on every update. Another alternative check is to check if the rotation over all the pieces is 0. Because whenever you rotate this guy, the rotations of each piece is going to be different. But if they're all rotated 0x, 0y, and 0z, you know it's in the win state as well. So that's a neat little trick you can do right there. So you can see here the code, check solve, get the pieces. And here's where I'm checking if the transform of the Euler angles x does not equal 0, or if the transform of the Euler angles y does not equal 0, and the transform of the Euler angle z does not equal 0, then return false. It's not in the win state. But if you get through all the pieces and they all got 0, 0, 0 for each of the rotations, then you know you've won. So that's where you drop down to return true right there. So I'm going to show you the demo right here that I created. So basically what I did this time, I have different commits for each like slide, each point. So if you want to see the beginning steps, just go back and look at the earlier commits. I'll put a link out to the Git repository if anybody wants to take a look at the code. But it's just going to be one repository with one set of code. But if you want to look at the earlier steps, go look at the previous commits. So yeah, here I have my piece prefab right here. Check it out right there. And by default, there's no color on any of the sides. You can see here, I created, this is the mesh right here and the different, like earlier I explained to split each of the sides out into a separate mesh. That's why that was important. And it pulled in the names. I can't remember if I had to change those or not. But basically I got a piece for each side. And then in the main piece object, I have the piece script right here. So I have public game objects right here and then a reference to the model. I set all of the values of each of the sides. So basically each color is going to be a value 0 through 5, I believe. So that's the int value. So I don't want to have to like be doing comparisons on color objects. So I just track it as an int value. And here's my list of materials right there. So that's all the piece object is. So here's the game manager right here. I guess I'll go ahead and play the demo first. So this is what it looks like. Let me get out right here. So let's go to, you can see right here, I can like rotate the right side. So I'm pressing R, L to rotate the left, U to rotate the top, D to rotate the bottom, F to rotate the front, and B to rotate the back. Can make that bigger like that. So the only thing that I don't have in this is automatic scrambling. So basically you got to scramble it yourself like in real life. I also don't have it where you can move the camera or anything, but if you go unmaximize that and pull this over, you can like make this size bigger, and you got to make sure that's selected over there. But you can see like on the invalid sides, you can see that there is no color where on the invalid sides of each of the pieces. So they're basically all still cubes, but only the sides that are showing have the actual color values on them. So let's stop this guy right there. The other thing that I was going to show is that you can see in the big thing here, it says, it's kind of hard to see, but it says solved. Not sure why that's blurry there. Maximize. Yeah, I have to look into that. But as I rotate it, the solved goes away, but then when it goes back to the, there it is, it cleared up. When it goes back to the solved state, then it knows it's solved, and that's by checking those rotation values. So you can do 1, 2, 1, 2, 1, 2, 1, 2, and then you know it's solved. So let's go back and look at the code real quick. So here's all the list of pieces, or pieces to rotate right here in our game manager. Our piece prefab right here, our rotation point. So you can do this. I started doing this like vector 3 question mark. I learned about that recently, so you can make it like a nullable vector 3 in case you want to put it in an invalid state. You can make it null. The only bad thing is you got to cast it back to a regular vector 3 to use it in a lot of functions. Want to keep track of rotation degrees, the rotate speed, 360 float, right there. So it's going to rotate 360 degrees in 1 second. So it rotates really fast. Like if I lowered this to 90 right here and save that and run it again. So it's going to rotate really slowly. It's going to take 1 second. 1 second to go 90 degrees. So 360 is pretty good. So it's going to rotate. It's going to do a 90 degree rotation in a quarter of a second. So it's pretty snappy right there. Front, back, up, down, left, right. Like I said, I know how to solve this, but this talk isn't on actually solving. There's a lot of other tutorials out there for solving the 3x3 cube that explain a lot better than me. I know the beginner method, which works pretty good, but that's not what this talk's going to be about. Here's our panel for displaying the solved. Here's our crate pieces. Here's where we're getting the input like I talked earlier. So I got a handle whether the U is pressed, the D is pressed, L is pressed, R is pressed, F is pressed, B is pressed. I don't have rotating in the opposite direction. That would be cool, like if you could hold shift or something and rotate it in the opposite direction. One other idea I had is like it'd be really cool to have this in VR. I don't know if I'll probably never have time to actually do that, but it would be cool to implement this in VR, like you're actually holding it in your hands. But then you're at the point why don't you just buy a real one? Okay, so create the pieces. I talked about this earlier. Here's where we're setting up all 26 pieces down through here. I guess I can make this a little bit bigger right there. Don't want it too big. So we'll loop through each of the pieces. Here's where I'm setting the colors. So this is where I use that math round to int, math f round to int. So if the z position is -1, we're going to set it to color 4, which z -1, that's probably blue. If z is 1, it's either blue or green. One of these is blue and one is green. If it's 1, that's probably the blue right there. We're going to set it to 5. If x is -1, if x is -1, it's going to be orange. If x is 1, then we're going to set it to 3, which is red. And if y is 1, it's going to be white, color 0. And if y is -1, it's going to be 1, which is yellow. So we could actually pull those up if we look at the piece prefab. I have it on the piece prefab, I believe. You can see here we got material E, material D, material L, material R, material F, and material B. And if I click on that, you can see there's the white material E, red material R, orange material L, green material F, yellow material D. That's just like the blank material right there, and back is blue material B. So you can see that's where we got 0, 1, 2, 3, 4, 5. And here's the int values right there. So here's our rotating layers. That gets called up here. So here's where we're, like for the front, we're clearing our list of pieces. Then we collect all the front pieces. We check using mathf round to int. Z position is -1. Then we add that to the list of pieces to rotate. Set the vector rotation point to 0, 0, -1. And set the rotation degrees to 0 to start out with. So here's our rotate layer. So if we have more than 0 pieces to rotate, we want to set the F rotation value. So rotate speed times time delta time. Rotate degrees, we're going to add F rotate. It's greater than, if the number of rotated degrees plus the rotation is greater than 90, then we want to rotate it by 90 minus rotation degrees. And then set the rotation degrees to 90. That's if we actually went past 90 right there. We're going to set it to 90. Else, we're just going to add F rotate to the rotation degree. F rotate is how many degrees it's going to rotate in that one update. Then we're going to set the rotation of each of the pieces. P transfer will rotate around, vector point, rotate right there. If the rotation degrees is greater than or equal to 90, then we're going to stop. Set the transform position to the new position right here using the round to int values for X, Y, and Z. We're going to clear our list of pieces rotate. We're going to check and see if it's solved. If it is solved, we're going to debug output. We're going to debug output either way. We're going to say whether it's solved or not. If it is solved, we're going to show the solved panel. Otherwise, we're going to hide the solved panel. Here's our check to solve. So I'm using the quick and dirty method right here. If all of the pieces, if the Euler angles for X, Y, and Z are all 0 for all the pieces, then the puzzle is solved. Now, the more, I think, logical method that I was talking about earlier, you want to check each of the sides to make sure each piece that's showing on that side matches the centerpiece. But since this works, I went with that. Here's like a little helper method. Actually, I don't think I even used this. That's why I was trying to do that other method that I just talked about. I was going to do a get piece at X, Y, and Z, but I didn't not even use that. Here's our show solve panel and hide solve panel. So you can see in our game manager right here, we have a reference to the panel solved right there. Have a reference to our piece and our panel solved. And our panel solved just looks like that. You can get real fancy with this. Make it look a lot better. But yeah, there it is. Right there. It's just a simple panel with a simple text. It says solved like that. So yeah, I didn't have a slide for it, but yeah, there's a lot of things you could do with this. I don't think there's a lot of puzzle cube games out there. I really haven't looked as far as like computer games, but you could add a timer to this, see how fast you can solve it. You can have different formations. You can have different colors for each of the sides. I don't know. You can get real wild with it. And like I said earlier, I didn't have the auto scramble. I didn't have enough time to do that. That's one thing I wanted to do, but just didn't have time to do it. So yeah, I had a lot of fun doing this. Like I said earlier, I had one of these guys when I was a kid, and I just recently learned how to solve it not too long ago using some good tutorials online. So that's kind of on my bucket list. It's like, hey, I never did solve this thing when I was a kid, so I was happy to figure it out. And I still practice a little bit now and then just to try to get faster and improve my time. But anyway, hopefully everybody found this interesting, and I'll plan on being back in a month. Thanks everyone for listening and watching.